All right, today we're going to be talking about and working with tangents. Tangents. Tangent. These are lines that intersect a circle. Intersect a circle. Lines that intersect a circle in exactly one place or in exactly one point. Called, this is tricky now, be careful. Lines that intersect a circle in exactly one point, called the point of tangency. It's a tricky name for that point. All right, so if you take a circle and then you draw a line, and the line just touches this circle in exactly one point. Right there. All right, that is your point of tangency. This line L would be called a tangent. All right, if this was point A here as the center of the circle, you could say line L is tangent to circle A at B, or point B. And then we've got some rules that apply to tangents. And here's the rule, one of the rules. We're going to say that if a line is tangent to a circle, then it is perpendicular to the radius at, and I'm going to go here, I'm going to call this POT. And POT means point of tangency. I don't want to write that out again. Here's P, O, T, and here's POT. And what this theorem says that if a line is tangent to a circle, then it is perpendicular to the radius at point of tangency. So if we take the radius and connect A and B right here, since B was our point of tangency, these two are perpendicular to one another. The radius and a tangent are perpendicular at the point of tangency. A radius and a tangent are perpendicular at the point of tangency. Okay? So now when you start seeing perpendicular and you start seeing 90-degree angles, start thinking about Pythagorean theorem, because that's where this thing moves into, or what it moves into. So here we go. This is a good question. If you're given this picture, and we've got this diagram going on, and this is triangle ABC, and then we've got a 9 and an 8 and a 15. The question is BC tangent to circle A? Is BC tangent to circle A? Well, it looks like it is, but in geometry, you're not really supposed to assume anything. Really shouldn't assume anything ever, okay? Is BC tangent to circle O, or circle A? Well, if AB and BC intersected at 90 degrees, then we would know that BC is tangent to circle A. Well, we could figure out this angle right here if we did the Pythagorean theorem. But before you do the Pythagorean theorem, be careful. Don't forget about this piece of the hypotenuse. Agreed? The length of that piece of the hypotenuse is a radius, isn't it? This is 8 as well, which makes this entire hypotenuse 17. So now what we're trying to decipher here is, does 8 squared plus 15 squared equal 17 squared? That's the question. If it does, isn't BC a tangent? All right. If 8 squared plus 15 squared equals 17 squared, then angle B is a right angle and BC is a tangent. So that's the question we're trying to answer. So we get a 289 here on the left, and we get 17x squared is 289. And they equal each other, don't they? So this is a yes, all right? This is a 90-degree angle. And is BC tangent to circle A? Yes. Everybody see that? Here's the piece that gets forgot about all the time. Right there. That's why I redded it in. People say 8 squared plus 15 squared equals 9 squared, and it doesn't work. And they go, well, no, it's not a right angle. No, it's not tangent. Well, you forgot about that 8 piece right there. And then you forgot to add the 8 to the 9. So be careful. That's a be careful spot right there. Got it? All right, second type of problem you'll see related to this theorem looks like this. Let's go here. Now you're told that J, I'm not J. G, we're going to say GH is tangent to circle J. All right. Here's the information, the other information. We've got an X right here. We've got an X right here. This piece is 8. And this piece is 12. And this point right here is K. You're told that GH is tangent to circle J. Well, if that's the case, if GH is tangent, then this is 90 degrees. And we have a right triangle. Now, here's your setup. And you got to be careful here. This starts bringing in some math that, oh boy, you haven't done in a while. All right. Look what's going on here. We're going to use the Pythagorean theorem to solve for x. But look at this hypotenuse again. What's the length of this hypotenuse? One piece is 8 and one piece is x. What is it? 8 plus x, or not 8x. Can we call it x plus 8? Very good, we can. So here's your Pythagorean theorem. This leg right here, G to J, is x squared plus the other leg of this right triangle is G to H, which is 12. So x squared plus 12 squared equals the hypotenuse squared. Well, here's your hypotenuse squared. X plus 8 squared. So what we get on the left-hand side is we get an x squared plus 144 equals x plus 8 squared. You did this back in Algebra 1. Watch. X plus 8 squared is the same as x plus 8 times x plus 8. And when you have a binomial times a binomial, you have to do the distributive property twice. So you have to do x times x, which is x squared, and x times 8, which is positive 8x. And then you have to do 8 times x, which is positive 8x. And then 8 times 8, which is positive 64. And then you have to combine your like terms in the middle of this expression. So what you end up with is x squared plus 16x plus 64. And that's what goes on the right-hand side of this equal sign. X squared plus 16x plus 64. And now you can do some moving and shaking to solve for x. So if you start, good morning, sir. Yes, sir. If you subtract x squared from each side, then 144 is equal to 16x plus 64. You can subtract 64 from each side. And 144 minus 64, that's 80. So we get 80 equals 16x. And then we divide by 16. And 5 is equal to x. And that was the original question. Find the value of x. So it's using the Pythagorean theorem, but a little bit of twist on the math, okay? If you've got to square a binomial, if you got x plus 8 squared, remember, that's the same as x plus 8 times x plus 8. Everybody okay with that? All right, so it looks like we got one more theorem here related to these tangents. And let's say that if two segments from the same exterior point are tangent to a circle, then they are congruent. If two segments from the same exterior point are tangent to a circle, then they are congruent. So here's what that looks like. Two segments from the same exterior point. So here's our exterior point. Call it A. Let's draw a circle. Put a point in the middle. That's circle B. And now, as careful as you can, make A tangent to circle B. And then, let's see, we'll call that AC. And then coming from this same exterior point, tangent to this same circle, we want this. We want this right here. So we've got 2 points of tangency. C is a point of tangency. D is a point of tangency. Since both segments are tangent to the same circle and they originate from the same exterior point, AC is congruent to AD. That's the theorem. And then they're going to throw some algebra in there for you to do. Like, they're going to tell you that AC is equal to 3x plus 8. And that A to D. Let's do this. Let's undo that. Not 3x plus 8. Let's make it 2x plus 9. Let's make A to D 3x plus 6. Let's make the question find the length of segment AD. So you see this diagram, you look at your rule, the two segments are tangent to the same circle, they originate from the same point, they're congruent to each other. We make our 2x plus 9 equal to our 3x plus 6. All right, we solve for x, then we substitute. So you can subtract 2x from each side. Nine is going to be equal to x plus 6. Can subtract 6. 3 would be equal to x. So there's your value of x. AD is represented by the expression 3x plus 6. So AD is going to be equal to 3 times 3 plus 6. And what's that equal to? 15. Very good. So that's what your AD is equal to. Everybody okay with that? Anybody got any questions on any of that? Okay, your practice for today. Back in that workbook. Let me show you one more thing before we, this one picture might, let me see if I can draw this. Sometimes it's a little harder to, you'd be better off just watching right here and not, I'll try to do this kind of quickly. Here's another application of this rule. And the question could be, find the perimeter of triangle ABC. Find the perimeter of ABC. And maybe this is a 4 and a 4, and then this is a 13, and this is a 15, and this is a 3x. Okay? That's what we got for information. So look, here's the rule though, right? Don't you have a segment, CAE and AD? Aren't they both tangent to the circle coming from the same point? So what do you know about those two segments? Right, so how far is it from A to D? Good. You see the same application here from C to D and C to F? So how far is it from C to D? All right, B to E and B to F, they're congruent. So 3x is, if they ask you to solve for x, you would do 3x equals 15. You would divide by 3. X would equal 5. But they're asking for the perimeter, so how far is it from B to F? 15. So then what you do is you just, what's side AB equal to? 19. And side AC is equal to, and then side BC would be equal to 28. So the perimeter would be equal to 19 plus 17 plus 28. So what is that? Anybody got that? 19 and 17 and 28. $64. So that's another application of that theorem, whether it's a triangle wrapped around a circle or a quadrilateral or a pentagon. All right. Anytime that you've got segments tangent to a circle originating from the same point, they're going to be congruent to each other. So your practice for today is page 131, workbook. Page 131, you're doing 1 through 8. Page 132, you're doing 1 through 7. You're going to put it in the basket when you're done. put in basket or email a pic. You have to show all your work. And you are still responsible to check focus for homework as well. Those are typically electronic questions that are related to the notes that you take in class. All right, so here's today's assignment. Study guide tomorrow. Quiz on Friday. E-learners, if you don't have a question, you're excused from the meeting. To complete your practice problems,